Today we're going to look at the inverse of an exponential function. So in order to do that, let's start off with the exponential function f of x. So here we have f of x is equal to 2 times 3 to the x minus 3. This is the function we're looking at. So first of all, let me remind you that the parent is going to be represented by the base to the x power without any transformations. So the parent for this function would be y equals 3 to the x power. Now, in a previous video, we went over the table for the parent. So we have negative 1, 1 over b. In this case, b is 3, the base, 0, 1, and then 1, b. Again, b in this case is 3. Okay? And then we applied the transformations here to the parent table. Notice there's no effect on the x, so the x stays the same. We're multiplying by 2 on the y, and we're subtracting 3. So we have two columns here for multiplying by 2 and subtracting 3. So we're also given in this function the y-intercept, which is going to be y equals negative 3. So graphing it, I graphed the dashed line for the horizontal asymptote, y equals negative 3. And that horizontal asymptote is always going to be associated with the k value for exponential functions. Then I went ahead and I plotted our new transform points and drew the graph. Okay, so now to get to the inverse. So we're going to go ahead and start by finding the inverse of the parent. And then we'll proceed and find the inverse of this function here. So recall that finding an inverse means first switching x and y. So that's what we're going to do first. We're going to switch x and y. So algebraically, we're going to walk through this over here. And then tabularly, we're going to see how the table differs from the exponential table above. So switching x and y, now we want to solve for y. So since y is in the exponent, we're going to need to take the log on both sides. So here we have the log of x equals the log of 3 to the y power. Then we can apply the power property and bring that y down front. And then we can solve for y. Since this is multiplication here, we undo multiplication with division. So we're going to divide both sides by the log of 3. And so then we would have the inverse. Now let me explain how I went from this to this. So I used a property called change of base property. So this is an important property to understand. So when you have the same base, this would be base 10, okay? And remember, base 10 is a common logarithm. It could be base 3, as long as the bases are the same, okay? Change of base, we can rewrite this like this. So the log in the numerator is going to be the argument. So we're going to be going from 2 logs down to 1 log. So the numerator argument is going to be the argument for our log. And then the denominator argument is going to be the base. Okay, so log of x base 3. That's how you would write that. Okay, so now let's go ahead and take a look at the table for our parent. So again, remember that to find the inverse, you are switching x and y. So technically, for the parent, we would switch the x and the y. So we'd have 1/3, -1. Switch the x and the y. 1, 0. Switch the x and the y. Switching them. 3, 1. Okay? So this would be the table for the inverse function for this function right here. Okay? So let's look at that in our calculators so that we can see this. So turning my calculator on, going to the graph screen. So the first thing I did here, well, this is the transformed graph, okay? So the transformed graph, this is actually the inverse for our transformed graph. So let me go ahead and start a new document. Okay. So our inverse parent is going to be log base 3 of x. Press enter. Okay. This is a graph of a logarithmic function. Control T. Now this first point in our table is not going to show up because our x's are integers, but the next point will show up, 1, 0, which matches this point right here, and 3, 1 right here. Okay, and remember we got these points from switching the x and the y above. Okay, so let's move on and let me explain how to find the inverse for this function. So let's walk through those steps. So the first thing we're going to do is switch x and y. Then we're going to solve for y. So before we take the log on both sides, okay, before we take care of this exponent here, we're going to need to undo adding and subtracting. So we're going to undo subtracting. Then we'll undo multiplication with division. I'm going to go ahead and leave this like this. I could convert it to 1/2 x plus 3/2, but I'm just going to leave it like that for right now. And since this is kind of a group here, I'm going to put a grouping symbol around it. So we're going to take the log on both sides because we want to get that exponent down front. So I did a couple steps here. Make sure you understand I took the log on this side, which allowed me to use the power property and bring that y down front. Then we're going to divide both sides by the log of 3. And then let's come on up here. So now we're going to use the change of base. So we're going to go from 2 logs down to 1. Okay, the numerator argument is going to be the argument for our new log. And the argument in the denominator is going to become our base. And that is going to be our inverse function for the exponential function. And to get our new points, very simply, we could put this in our calculator and go to a table, or we could just switch the x and the y to get our new points. So if we switch these, it's going to be -2.3, -1. Switching these two, we get negative 1, 0. And finally, switching these last 2 points, we get 3, 1. So there's 3 points on our inverse function graph. All right, I'll see you in class tomorrow. Thanks for watching. I appreciate it.